Okay, this is page 4, example 1. Find the equation for the ellipse with the two given focus points and the sum of the focal radii is 10. So what that means is this. The center of an ellipse is midway between the focus points. So the center would be 0, 0. And this could be one focus point, and this could be the other focus point. And then if the sum is 10, if I drew a sketch, it's going to look something like this. These are the so outside of the focal radii, the ellipse is going to go something like this. Like that. So any point on the ellipse, if I connect to the two focal radii, the sum is 10. So to come up with the equation, we could do it this way. In general, if we picked any point on the ellipse, we can call it x comma y. We know the sum of these distances are the same. And if this point is -4, 0, and this point is 4, 0, I could use the distance formula and set these equal. So it's x minus -4 or x plus 4 squared. This is the distance from point P to F1, plus y2 minus y1, y minus 0 or y squared. And that's going to equal, and that plus the distance from P to F2 must equal 10. So P to F2, if we find this distance between these 2 points, it would be x minus 4 squared plus y minus 0 or y squared. And the distance formula is really the square root equals 10. Distance formula is square root of x2 minus x1 squared plus y2 minus y1 squared. Now, to get this equation in better form, what we could do is this. If right now we have this, eventually we'd have to square each side and isolate the radical. Eventually, when we work this out, we can come up with an equation. And let me just sort of go through where the equation comes from, because this will be easier. On the bottom of this page, foci on the x-axis, c comma 0 and negative c0. Here's your basic equation. We're going to sort of work backwards to develop the equation. Equals 1. Foci on the y-axis, the equation is just in reverse. And it says the sum of the focal radii for each of the points is the constant 2a. And c squared equals a squared minus b squared. So in general, if we have an equation where the major axis is the x-axis, the x-intercepts are a comma 0 and negative a comma 0. And the y-intercepts are 0b and 0 negative b. If the major axis is the y-axis, in this case, the x-intercepts are plus or minus b comma 0. And the y-intercepts are 0 comma a comma 0 negative a. And it says in each case, the ellipse is symmetric with respect to both the x and the y-axis. Major axis is the segment of length 2a cut off by the ellipse. Minor axis is the segment of length 2b that's perpendicular to the major axis at the center. So for us to come up with the equation here, we would have to do this. We'd actually have to do the algebra to simplify this. So it would be a lot of work. And eventually, as we do some other problems, we're going to get to it easier. I'm just expanding this. And then what you would have to do, if I move this to the other side, we would then have to square each side. Plus 16 plus y squared. and then you'd have to square each side, which is going to end up being pretty messy. So easiest way for us to understand it without going that route is this. So if the center is midway between the focus points, we know it's going to start x squared and y squared because the center is 0, 0 in general. And if the focus points are left and right 4 from the center, we know the major axis is x. So this is going to be the bigger amount, which is going to be a squared, and this is b squared. And we know the sum of the focal radii is 10. So if the sum of the focal radii is 10, we could set 2a equal to 10. And if we do that, we get a equals 5. So 5 is going to go in here, and 5 squared is 25. And then to figure out b squared, we're going to use this equation. C squared, which is, we're trying to find, or c squared equals a squared, which is 25 minus b squared. Well, c is the distance from center to focus. So from 0 to 4, 0, or to negative 4, 0, that distance is 4. So that's 4 squared, so that's 16. And then if we solve for b, we get this. Negative 9 equals negative b squared. So if b squared equals 9, that goes in here. So anyways, you can use the distance formula to develop an equation, but to come up with this equation, that's going to take a lot of work. Easiest way is to just solve for a squared and b squared, and we can do it because if the sum of the focal radii is 10, we could just set 2a equal to 10. So those are the notes from page 4 from chapter 10.